Hello everyone. In today's lecture, we are going to learn about the graphs of the different trigonometric functions. We will start with the sine function graphs, talk about its properties, the shape of the graphs, and then we will also talk about the transformations and translations of the different graphs. Then we will move along to the other trigonometric functions like the cosine function, tan function, and the different reciprocal function graphs. Here are the topics that we are going to cover in this lecture. We are going to start with our study of the sine function graph, understand its properties, its behavior, its shape. Then we are going to go into understanding the variations of the sine function graphs, the different translations and the transformations, and then we will move on to the cosine function graphs. We will also see how that compares with the sine function graphs. We are going to use vertical shifts of sine and cosine curves, and finally learn how to model periodic behavior. We'll begin by studying the graph of the sine function first. As with drawing any other graph, we will first have to obtain some points using the different x values, plugging those into our sine function, and then obtaining some y values, which will give us a bunch of xy coordinate pairs. And once we have those values, we are going to plot them on the xy coordinate plane, connect them, and obtain our graph. Here on this table, they have chosen x values between 0 radians and 2 pi radians, and some special angles in the different quadrants of the unit circle. So as we can see, they have 0, then pi over 6, pi over 3, pi over 2. Then in the second quadrant, it's 2 pi over 3, 5 pi over 6, until we get to pi, then 7 pi over 6, 4 pi over 3, 3 pi over 2, which is pi over 2, pi, 3 pi over 2, and 2 pi. These are angles on the x-axis or y-axis, correct? So they have the corresponding y values here. However, let's make some observations on the y values. What happens to the y values for the different x values up here? All right. In this picture of the unit circle, when x is 0, y is 0. As x increases, pi over 6, pi over 3, what happens to the y values? The y value represents the vertical distance, correct? So the y values increase from 0 to 1/2, and then as we go to pi over 3, the vertical distance increases further. We have a vertical distance which is greater than what it was at pi over 6 until we get to pi over 2, where y has a value of 1. And that is the highest value that the sine function is going to take. What happens to the y values in the second quadrant? At 2 pi over 3, we have the same distance as we had at pi over 3. This distance and this distance are same, but the y value has decreased from its peak value of 1. As we go to 5 pi over 6 radian angle, the y value has decreased further from what it was at 2 pi over 3. However, it's going to have the same value, the same distance as what it was at pi over 6. So let's look at the values on the table. You'll note here that we start from 0, and then the y values increase all the way up to 1 at pi over 2. Then in the second quadrant, the y values start decreasing. From 1, it becomes again square root over 3 by 2, which is the same as what it was at pi over 3. And then 5 pi over 6, the value decreases further from what it was at 2 pi over 3. It becomes 1/2, but it's the same as what it was at pi over 6. At pi, the y value is 0 once again. And then for the third quadrant angle, let's say 7 pi over 6, we get a y value which has the same distance as what we had at 5 pi over 6 or pi over 6, but this is a negative value, a negative y value. So at 7 pi over 6, the y value is negative half. The distance is the same. Right, the absolute value, the distance is the same as what it was at 5 pi over 6 or pi over 6, but it's on the negative x-axis, so it's a negative value. Then as we move further to the next angle, which is 4 pi over 3, we get a y value which has decreased further from what it was. So negative half, we have negative square root over 3 by 2, which is less than negative half. And then at 3 pi over 2, we have a value of negative 1, and that's the lowest value that the sine function is going to take, because for the angles in the fourth quadrant, which is 5 pi over 3, the y values start increasing again from negative 1. So from negative 1, it's square root over 3 by 2. And then at 11 pi over 6, it's negative half. And then finally at 2 pi, we come one full circle back to 0. So once we have these values, we plot them on the xy coordinate plane and just observe the scaling of the x and y axis. On the y axis, we do not have values less than negative 1, so we go as low as negative 1. And on the positive y axis, 1 is the highest value the sine function will take. Therefore, we keep it at 1, and then we have the x values scaled on the x-axis starting from 0 at the point of intersection between the two axes, and then we plot our points. We start from 0, the y values keep increasing, reaches the peak at pi over 2, and then starts dropping symmetrically as we go towards pi, where the y value becomes a 0, and then we have values on the negative y-axis. We have all negative values from pi to 2 pi until we get to 0 at 2 pi. Now that we understand the behavior of the graph of the sine function, let's study some of the properties of the graph. Let's first talk about the domain and the range of the function. The domain of the function is from negative infinity to positive infinity. What do we understand by the domain of a function? It is the set of all the x values that can be input into the function, which would produce a real number for the y value. If you look at this picture here, they've extended the x-axis in the negative direction as well, and you can keep extending the x-axis all the way to negative infinity and positive infinity, and you will always get y values which are real numbers, all values between negative 1 and positive 1. So the range represents all possible y values that can be output when you plug in a certain x value into the function. And that is for the sine function, negative 1 and positive 1 inclusive, and everything in between these range of values. The period is 2 pi. What do we understand by the period of a function? It is the interval within which the y values have a unique pattern. After every 2 pi period interval, the y values will keep repeating, whether on the positive side or on the negative side. So that is what the period of a function is. It is the interval within which the function will have unique y values. It will have a unique pattern. Finally, it says here the function is an odd function, that is sine of negative x equals negative sine of x. What this means is if we have a negative of an x value, if we plug in a negative of an x value into the sine function, the output, the result, the y value will be negative of what it was when x was positive. For example, if you look at this graph, at pi over 2, y had a value of 1. So sine of pi over 2 equals 1. If we change the pi over 2 into negative pi over 2, we should get a negative 1. Negative of what we had when it was a positive x value. So let's look at here in the graph. This is pi over 2. On the negative x-axis, this point would be negative pi over 2. And look at the value of y here. It is the negative of what we had for pi over 2, correct? It's negative 1. So that's what we understand by an odd function. Next, we are going to go through some examples of graphing the sine function. However, here, let's go through some steps which will hopefully make the process of graphing a little bit easier for us. We start with identifying the amplitude and the period of the graph. We'll talk more about the amplitude. However, for now, just understand it represents how far the graph is going to rise above the x-axis or fall below the x-axis. The period represents the interval within which the graph is going to follow a unique pattern. For the next step, find the values of x for the 5 key points. What are the 5 key points? They are the 3 x-intercepts, the maximum point and the minimum point. We start with the value of x, where the cycle begins. For the sine of x function, we begin from 0 and add quarter periods. And the quarter periods would be determined by taking the period for the sine of x function. It'll be 2 pi divided by 4 to find successive values of x. If we start from 0, then the 5 key points are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. For step number 3, once we have our 5 key points, we have to calculate the corresponding y values by plugging in the values of x into the sine function. So find the values of y for the 5 key points by evaluating the function at each value of x. And then once we have the different coordinate pairs, we are going to plot them on the xy coordinate plane, connect the points with a smooth curve, and finally we are going to extend the graph that we got in step 4 for one complete cycle. We are going to extend that to the left and right because the pattern is going to repeat itself after one cycle. We are now going to work on an example of graphing a variation of the basic sine function. The question here says, determine the amplitude of y equals 3 times sine of x, then graph y equals sine of x and y equals 3 times sine of x in the interval minus pi and positive 2 pi. So first we have to determine the amplitude of each of these functions. We've been given two functions, y equals sine of x, which is the basic sine function, and the other one is a variation of the basic sine function. Now, if you look at the form of the second function, it has a visible value, a visible number before sine of x, and that gives us a form which is known as y equals a times sine of x, and the value of a gives us the amplitude of the function. Now, even the basic functions can be written in this form. For example, when it's y equals just sine of x, when you do not see a visible value before sine of x, that means the value of a is a 1. And when the value of a is 1 in the basic sine function, we all know that the range of the function is -1 and +1. So a essentially gives us the range of the function. In other words, how much the graph is going to rise above the x-axis or fall below the x-axis. What is the maximum y value going to be, or the minimum y value going to be? When it's the basic sine function, the minimum y value is a -1, the maximum y value is a +1. When we have the equation y equals 3 times sine of x, then the value of a is 3, and that tells us that the maximum value of y is going to be 3. The minimum value of y for this graph is going to be negative 3. So what we are going to have essentially is a sine graph for the sine of x for the basic function. It goes as high as positive 1 and as low as negative 1 for the y values. So our graph is going to go, if you have a 0 and then pi over 2 and then pi, then 3 pi over 2 and then 2 pi, then for the basic function it's going to look like this. Whereas for the second graph, we have to show a positive 3 and a negative 3 along the y-axis. So somewhere here, let's say there's going to be a positive 3 somewhere below. Down here, there's going to be a negative 3, and our graph is going to rise as high as positive 3, and then it's going to come down to 0 and then go as low as negative 3 and then come back again to 0 at 2 pi. So let's see if that's the graph we get. In the next slide, we are going to talk about step 2, which is determining the intervals of the x values. In step 1, we learned how to determine the amplitude and the period of the two functions whose graph we've been asked to draw. In step 2, we have to find the 5 x values which are going to serve as key points. We are going to use those key points to scale the x-axis over which we are going to draw our graph. Now, there's a process for doing that. To generate x values for each of the 5 key points, we begin by dividing the period. For the sine function, the period is 2 pi. So we begin by dividing 2 pi by 4. And when we do that, 2 pi divided by 4 is 1/2 pi, therefore it's going to be pi over 2. And this pi over 2 is essentially the distance between each of the 5 x values, 5 key points. So let's follow the steps that come up here. First, they are dividing the period by 4, which is pi over 2, and that is going to be the distance between each of the x values. We next determine the first x value, and it's going to start at 0 over here. X sub 1 equal to 0. That's the first x value. To find the next x value, all we do is add pi over 2 to x sub 1, so 0. So 0 plus pi over 2 is pi over 2. The next x value is going to be pi over 2. For the third x value, we take the value of x sub 2, pi over 2, and add another pi over 2 to it, and we end up with a pi. Then for x sub 4, it's the value of x sub 3, which is pi, and to it we add pi over 2, which gives us 3 pi over 2, and finally it's going to be 3 pi over 2 plus pi over 2 for a value of 2 pi. So the 5 key x value points are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. In step 2, we found the 5 x values which are going to serve as our key points. In step 3, we evaluate the corresponding y values for each of these x values. In other words, we are going to plug in these x values into the sine function. In this case, y equals 3 times sine of x, and find an ordered pair. We're going to put together the x value with the calculated y values and come up with an ordered pair. So let's go through it one x value at a time. For x equal to 0, y equals 3 times sine of 0. When x is 0, sine of 0, the y value is 0. So we have to multiply that 0 by 3. 3 times 0 is 0. At x equals pi over 2, it's going to be 3 times sine of pi over 2. Sine of pi divided by 2 is 1. We have to multiply that by 3, and the value is 3, so we are going to write pi over 2 comma 3. Here we are evaluating the values of the second function. We already know the values of the sine function, but here we are finding the specific values of x and y for the second function. When x equals pi, we are going to have 3 times sine of pi, which is 3 times 0. Y is 0 at sine of pi. So take that value, multiply it by 3, and we'll end up with 0. The next one is 3 pi over 2. Let's evaluate that. Y equals 3 times sine of 3 pi over 2. Sine of 3 pi over 2 is -1. Multiply that by 3. We get -3. And finally, for 2 pi, we should have 3 times 0, which is a 0. So they've listed the x and y pairs. We'll have 0, 0, pi over 2, 3, pi, 0, 3 pi over 2, -3, and 2 pi, 0. And now we are going to plot these points and complete our graph. Finally, we are ready to draw our graph. We use the 5 coordinate points we found in step 3. We plot them on the xy coordinate plane, and we connect them with a smooth curve and graph one complete cycle of each given function. I'm going to pull up the picture here. We see that the x-axis has been scaled with the 5 key points starting from 0, then pi over 2, pi, 3 pi over 2, and then 2 pi. The y-axis has been scaled between 0 and 4 on the positive side and between 0 and -4 on the negative y-axis, and this black curve is that of the basic sine function, and that extends along the y-axis to a maximum of 1 and a minimum of -1. As far as this red graph, which is of y equals 3 times sine of x, the only difference is that this rises to a height of 3 units along the y-axis and 3 units down to -3 along the negative y-axis. All right? Here we will talk about another variation of the sine function, which is a times sine of b times x. Previously, we talked about a times sine of x, where the sine of x function value was being multiplied by a. In this case, we have a times sine of b times x. So not only is sine of x being multiplied by a, but x is also being multiplied by another value, which is b, and that value better be a value greater than 0. So it's going to look like a times sine of b times x. Now, the effect that has on the graph is it changes the period of the graph. It does not have an effect on the amplitude. The amplitude is going to be the absolute value of a. However, the period is determined by dividing the normal period, the regular period, divided by whatever value this b is. So we are going to talk further on that and also work through an example. Here's an example of graphing a function which is of the form a times sine of bx. The particular example that we have to graph is y equals 2 times sine of 1/2 x. So in this form, we first need to identify the value of a and the value of b. So the form is a times sine of b times x. So a has a value of 2, and that's the amplitude that's going to tell us how much the graph is going to extend or fall along the y-axis. And b has a value of 1/2, and this value is going to affect the period of the graph. Now the overall steps of graphing the function will remain the same. Step 1 is to identify amplitude and period. So we just look at the value of A, and it tells us that the amplitude is going to be 2 because A has a value of 2 here. And for the period, we have to look at the value of B, and the normal period of a sine function is 2 pi. Just divide that by whatever value B has. 2 pi divided by 1/2 is 4 pi, which tells us that the graph is going to extend between 0 and 4 pi. One cycle of the graph will be completed not between 0 and 2 pi, but this time it will be between 0 and 4 pi. Therefore, the maximum value of y is 2. The minimum value of y is -2, and that is determined by looking at the value of A. The period of 4 pi tells us that the graph completes one cycle from 0 to 4 pi instead of from 0 to 2 pi. In step 2, we will be finding the values of x for the 5 key points. The process is pretty much the same. We take the period, but the period of the function whose graph we want to sketch. In step 1, we found the period was 2 pi divided by 1/2. It gave us a period of 4 pi. Therefore, take the 4 pi divided by 4 and you get a value of pi, and that tells us that the distance between each of these points is going to be pi units. And then we start with x sub 1 equals 0. That's the first x value. To find the subsequent x values, we keep adding pi, that value of the distance, to get the next x point. If we start with 0, to find x sub 2, add pi to 0 and you will get a pi. For x sub 3, we add 1 pi to this pi of x2 and that will give us 2 pi. For x sub 4, it's 2 pi plus pi, 3 pi. For x sub 5, it's 3 pi plus pi, which is 4 pi. In step 3, we will be finding the y values for the different x values we obtained from step 2. We will be plugging in the x values, these 5 x values, into the equation which is 2 times sine of half x, and do the evaluation and find the values of y and list them as ordered pairs. So when x is 0, we are going to plug in 0 into x. So it's going to be 2 times sine of half times 0. Half multiplied by 0 is 0, so we end up with 2 times sine of 0. Sine of 0 is a 0. 2 times 0 is 0. So y is 0 here. Coordinate pair is 0, 0. When x is pi, we substitute pi into x and we get 2 times sine of half pi. Half pi is the same as pi over 2. Sine of pi over 2 has a value of 1. We multiply that 1 with the 2 and we end up with 2 as the value of y. The ordered pair is pi, 2. In this way, we go through all the x values, we evaluate the equation and come up with these 5 ordered pairs. And once we have them, we'll be ready to plot the points on the xy coordinate plane, connect the points, and get our graph. In step 4, we plotted the 5 coordinate pairs that we found in step 3. We connected the points with a smooth curve, and this figure looks pretty much like what we had when we worked with the equation a times sine of x, but this time what will be different is the period over which the graph completes one cycle. It's no longer 2 pi because we had half for the value of b. Our period changed to 4 pi instead of 2 pi. So the x-axis is scaled as 0, pi, 2 pi, 3 pi, and 4 pi. The amplitude is 2, so it extends 2 units above the x-axis as the maximum value of y and 2 units below the x-axis. So the minimum value of y is -2. The maximum value of y is +2 because the value of a in the equation, which represents amplitude, was equal to 2. Now, if the question says to draw the graph over the interval 0 to 8 pi, then all you need to do is extend your x-axis beyond the 4 pi and scale it as 5 pi, 6 pi, 7 pi, and 8 pi. And we had one cycle of the graph going from 0 to 4 pi. Just repeat the cycle again from 4 pi all the way to 8 pi. And that is going to be the final step where we extend the graph in step 4 to the left or the right as the question asks you to. In this case, we extended the graph to include the interval between 0 and 8 pi. So the extension was in the positive x-axis direction. If the question said interval should be -2 pi to +2 pi, then we had to show the negative x-axis and scale it. All right? We will now talk about introducing a third variation to the sine function graph. Previously, we learnt of the variations up to a times sine of bx. Now we are going to subtract a quantity from bx. We'll name that quantity c, surround it with brackets because this portion of the equation will need to be calculated first, then its sine function evaluated, and then that value will be multiplied by a to get the value of y. Now, what does subtracting c from bx do to our graph? It introduces what's called a phase shift. A phase shift refers to the sliding of the graph along the x-axis. The graph could slide to the right of the point of origin, or it could slide to the left of the point of origin. There is a way of determining in which direction the graph would slide horizontally and by how many units. The way to do that is you take the value of c and divide it by b. If c divided by b is a positive value, that means if it's greater than 0, then the graph will slide c divided by b units to the right of the origin. If c divided by b is less than 0, in other words, if it is a negative value, then the graph is going to slide to the left of the point of the origin by c divided by b units. And c divided by b, this quantity, is called the phase shift of the graph. The amplitude is still determined by the value of a, and the period of the graph is calculated using the formula 2 pi divided by b, where 2 pi is the period of the basic sine function. All right? We are now going to work on an example that includes the third variation that we just learnt about of introducing a phase shift or a horizontal shifting to the graph. The question here says determine the amplitude, period, and phase shift of y equals 3 times sine of 2 times x minus pi over 3 within brackets. Then graph one period of the function. Now we should be able to recognize that this form of the equation is the same as what we learnt, a times sine of within brackets bx minus c. And once we can recognize the form of the equation, we should be able to identify the values of a, b, and c. The value of a is 3, the value of b is 2, and c should be positive pi over 3. And once we have that, we can determine the amplitude, period, and the phase shift of the graph. So they have the equation written here. We have the values of A, B, and C identified just like we did above. A has a value 3, B is equals 2, and C equals pi over 3. It's a positive pi over 3 because C is the value after the negative sign. Whatever comes after the negative sign. So it's a positive pi over 3. What is going to be the amplitude is the value of A, which is 3. So absolute value of A, which is the absolute value of 3, which is positive 3. What does the amplitude refer to? It tells us the maximum point that Y will take above the x-axis and the minimum point the Y will take below the x-axis. And that will be positive 3 above and negative 3 below. The next is finding the period of the graph. Now, period is given by the formula 2 pi divided by whatever value b is. B has a value of 2, so 2 pi divided by 2 is pi. Therefore, the period of the graph should be pi units. 2 pi divided by b equals 2 pi divided by 2 equals pi is just what we did above. And then we have to also know what the phase shift of this graph is going to be. What was the formula to find the phase shift? It's take the value of C and divide by B. C divided by B tells us how many units it's going to shift horizontally. The graph is going to shift from the point of origin horizontally, and if C divided by B is a positive value, then it's going to shift to the right. If it's a negative value, it's going to shift to the left, correct? Therefore, to find the value of the phase shift, we take the value of C, which is pi over 3, divided by the value of B, which is 2, and then pi divided by 3 times 1/2 is pi over 6. So that tells us that the graph is going to shift pi over 6 units to the right, because pi over 6 is a positive value that we got. It's going to shift to the right from the point of origin. In step 2, we find the values of the 5 x key points, which will then be used to scale our x-axis, over which we are going to draw one cycle of the graph. First, though, we have to determine the distance we must place between each of the 5x values. And that is determined by taking the period that we found in step 1 for the function that we are working with and divide that period value by 4. So in step 1, we saw that the function had a period of pi, so pi divided by 4 is the distance that we must place between each of the x values. But where will the graph begin from? Because this particular function, recall, has a phase shift in it. And we came up with a phase shift value of pi over 6. That means the graph is not going to begin from the point of origin, but it's going to shift pi over 6 units to the right. Pi over 6 is a positive value. Therefore, it tells us that it's going to be a horizontal shift to the right. So the starting point of the graph is going to be at pi over 6. Therefore, x sub 1, which is the first x value, is going to be at pi over 6. How do we come up with the values of pi over 2, pi over 3, and so on? To pi over 6, we will add this distance of pi over 4, and we get a value of 5 pi over 12 when we complete the addition of pi over 6 and pi over 4. For x sub 3, we will add again pi over 4 to 5 pi over 12, which is the point for x sub 2. And we should get a value of 2 pi divided by 3. Then we'll take 2 pi over 3, add pi over 4 to it to get x sub 4, we get a value of 11 pi over 12. And finally, for x sub 5, we take 11 pi over 12. To it, we add pi over 4 to get a final value of 7 pi over 6. So the graph is going to start from x sub 1 equals pi over 6 and end one cycle at 7 pi over 6. All right? Step 3 is about finding the y values by plugging in the different x values into the equation whose graph we are trying to sketch. The equation here is y equals 3 times sine of, within brackets, 2x minus pi over 3. The first x key point that we found is pi over 6. Plug in the pi over 6 into x and we get 2 times pi over 6 minus pi over 3. We first have to evaluate what's within the brackets. So 2 times pi over 6 is pi over 3. And then when we subtract pi over 3 from the first term, pi over 3, we get 3 times sine of 0. Sine of 0 is 0. We multiply that by 3 and we get 0 for our y value. For the next key point, which is 5 pi over 12, again plug in 5 pi over 12 into x. Perform the calculation within the brackets first, so you know what sine function you have to calculate, and then multiply that by 3. So we end up with 3 times sine of pi over 2. Sine of pi over 2 is a 1. Multiply that by 3. So our y value is a 3. Our ordered pair is 5 pi divided by 12, comma 3. In the same way, we go through all the other 3 x values. For 2 pi over 3, we get 0 for our y value. And then for 11 pi over 12, the y value is negative 3. For 7 pi over 6, the y value is 0. We are finally at the step where we plot the 5 coordinate pairs that we found in step 3. Connect the points with a smooth curve and graph one complete cycle of the function. Now recall that this function had a phase shift of pi over 6 units to the right of the point of origin. This function also has an amplitude which is 3. Therefore, the graph will rise 3 units above the x-axis and fall 3 units below the x-axis as well. So the amplitude of the graph is 3. The phase shift is pi over 6. Now this section of the graph between 0 and pi over 6 is really an extension of the sine function.